Alright friends, in this question we are given, consider a drop of rainwater having mass 1 gram falling from a height 1 kilometer. It hits the ground with speed 50 meter per second. Take g constant with value 10 meter per second square. The work done by the gravitational force and the resistive force of air is. Okay, there are two work done. We need to calculate, one by gravitational force, one by the resistive force. First of all, work done by gravitational force. This will be force into displacement into angle between the two. Gravitational force is acting downwards, and same is the direction of displacement, say, which is h, and so angle between them is 0, so we get mg into h into cosine 0. We are given g is constant, so we can take the force as constant here, because g actually varies with height, but it's given to us as constant, so we'll take that as constant here. Now we fill the values. Mass is given to us as 1 gram, that is 10 to the power minus 3 kilogram. G will take as 10 because it's mentioned as 10, and h is 10 to the power 3 meters, that is 1 kilometer. So we fill that values. This gets 10 to the power minus 3, 10 to the power 3 cancel out. We are left with 10 joule of work. So this is by gravitational force. Given to us in option number 3. So correct option should be this one, because no other option is actually matching, but we'll confirm it by calculating resistive force. Now resistive force of air, how do we calculate that? Let's use the work energy theorem. Following the work energy theorem, change in kinetic energy is equal to the net work done, which is work done by gravitational force but plus work done by resistive force. So work done by resistive force will be equal to change in kinetic energy minus work done by gravitational force. So this is half mv square. Change in kinetic energy is half mv square minus 0. Initially there was no kinetic energy with the drop, so this is equal to mgh plus rf. Mgh we have already calculated as 10 joule, so that means work done by this resistive force of air, this will be equal to half into mass m is 10 to the power minus 3 into v square. Velocity is mentioned here 50 meter per second, so 50 square minus mgh we had calculated as 10. So this, when we solve, this gets 50 square is 2500 divided by 2 is 1250 multiplied by 10 to the power minus 3 is 1.25. So we get 1.25 minus 10. This is minus 8.75 joule, which is given to us here in the second part of the question, in the option number 3. So the correct option is option number 3 here.